In today's video, we are going to be graphing linear reciprocal functions. So our linear equation is mx plus b, so y equals mx plus b. Reciprocal, when we say the reciprocal of something, so let's say we have the number x, and we're actually the reciprocal of that. What that just means is, no, this is x over 1, we're just going to flip it, and it's going to be 1 over x. So this is going to be the reciprocal of whatever that is, where x is not equal to 0 in this case. Okay, some key terms that we're going to need to learn would be our vertical asymptote and our horizontal asymptote. Yeah, VA and HA. And what these are lines. So a vertical line where our graph is going to approach that line, but it's never going to touch it. So, for instance, let's say we have a graph like this. Our vertical asymptote is a vertical line. And let's say we have a graph. So our graph is going to move so close to that line, but it's just never going to touch it. Right? And something like that. And we also have our horizontal asymptote. So now this time it's horizontal. Give me one sec. It's horizontal. So right here. Our line, this line that we were moving, is going to go really close, but it's never going to touch it. And that's what those mean. I'm going to be using HA and VA throughout. And we also have points that are called our invariant points. And these are points that are the same for both our linear graph and our reciprocal graphs. So we're going to be taking linear graphs, we're going to turn them to reciprocal graphs, and so on. And so to find our invariant points, we're going to have to set y equal to 1 and y equal to -1. Don't worry, this all seems confusing. We're going to get into examples. Okay, so if we're asked to graph y equals 1 over x, subtract 3. The first step is we're going to graph this as a linear function. So we're going to graph a linear function first. So we're going to have a graph here. Let's move this up. Okay, so we're going to graph this as a linear function. And what that just means is, your line. So we're going to graph a line. And to graph a line or your linear function, what you need to know is plot your y-intercept. And in your linear function, which is mx plus b, your plus b is your y-intercept. So here in this question right here, -3 is our y-intercept. So we're going to plot that on here, -3 right here. And then the next thing is to plot the slope. Okay. Our slope is our m in our equation. And in this equation, we're not given a slope. So you can't really say it, but there's an implied one. Because here, m is multiplying x. So here as well, there's an implied 1 here for m. There's an implied 1 there. And what that means is that 1 is multiplying 1 over x. Remember, this is a reciprocal, right? So we're going to graph our slope, which is 1. So we're going to go up 1 to the side 1 point, up 1 side 1 point, up 1 side 1 point, down 1 side 1 point, down 1 side 1 point. So something like this. Then we're going to have our line that goes through it. Actually, I'm gonna have a line that goes through that. Hopefully that's straight enough. So we've plotted that. So now the next thing is we need to find our HA and our VA. So our horizontal asymptote and our VA. In this going for this lesson, we are going to always assume that our HA is at y equals 0. So HA would be at y equals 0. So right here, that's where y equals 0. This is going to be our HA. Now to find our VA, we're going to set y equals 0 and solve for x. So y is going to equal 0, so we're going to have 1 over x, subtract 3. We're going to add 3 to both sides, equal to 1 over x. So we have 3. So basically, our vertical asymptote is at a 3. So we're going to just put that for 3. Just dotted lines or dashed lines. So this would be our VA. Forget about the 1 over x. Again, this is the reciprocal. I should have put that as an x. Doesn't really matter right now. So we have our VA. So now the next step is to graph our reciprocal graph. So now we're looking a lot at that. We're going to graph that. And the first thing is to find our invariant points. And our invariant points, like I said before, is at y equals to 1 and when y is equal to -1. So here, we're going to take our equation instead of 0. We're going to make y, I already solved this, I'm going to erase that. We're going to make y equals to 1 first, and then we're going to do -1 after. So then this is going to be 1 plus 3 equals 1 over x. So this is going to be 4 equals x. So at 4. And we're going to do the same thing, but we're going to do it with -1 this time. So equals 1 over x minus 3. And this is going to be plus 3 to both sides, right? So this is going to be 2 equals 1 over x, or x. So now our invariant point is when y is equal to 1, x is equal to 4. So we're going to go 1 and then go 4. So our invariant point would be somewhere around here. And then when y is equal to -1, it's going to be 2. So we have our invariant points right there. Then the next step would be to choose points on the graph, on the linear graph. So whatever point we want. So we already know this point right here, this point, and this point. So we can choose other points on the graph, whichever points that we want. So I'm going to choose this point right here. And this point is 1 and -2. And then what we're going to do is we are going to reciprocate the y value. Wow, this is a lot of information. So what we're going to do is we're going to reciprocate the y value. So what that means is that point here is 1, -2. We're going to reciprocate. We're going to take the reciprocate of just the y. So it's going to be 1 and 1 over -2, right? Because the reciprocate is flipping it. So it's going to be 1 over -2. And now we're going to plot that point. So now our point is going to be a lot smaller. So we're going to go 1, where x is 1, and where y is -1/2, and y is -1/2, somewhere around here. So it's a lot smaller. And then we can choose another point. I can choose a point to this side of the graph. I'm going to do 5, so right here. Actually, I'm going to do 5, and when the graph is at 5, it's going to be at +2, so +2 and 5, that point right here. So this is 5 and 2. Again, we're going to take 5, take 2. We're going to reciprocate the 2, so it's going to be 1 over 2 this time again. So we're going to go to 5, and then our point is going to be way smaller. It's going to be somewhere around here. Okay, so that's going to be our new point. And then the next thing to do is to join this together. You could repeat the steps again for the other side, but to get more points. But we're going to join it together. But we have to remember the asymptotic behavior. And what that is that your graph is going to come really, really close to your VA and your HA, so your vertical asymptote and your horizontal asymptote, but it's not going to touch it. So we're just going to take our invariant point right here. We're going to go to the point that we just found. So we're talking about this point right here and this point right here. Not this one. This one was just used to find this point and that point. And we're going to just go really, really close to our VA, but not touch it. Really, really close to our, HA and VA, but not touch it. We're going to do the same to this side. We're going to go really, 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 really close to our VA, but not touch it. And really close to our HA, but not touch it. And that is how we would draw this graph. Just going to elongate this earlier. Wow. Super, that's a lot of information. I'm going to have step-by-step to follow in the description box, so go check them out. I find that when you see the steps, it's really helpful to kind of know exactly how to do it. So I'm gonna have that in the description box, so go ahead and check that out. But that would be it for today's video, because this is a lot of information. I don't want to bombard you guys with information, and I will see you guys in the next one.